go should start now. Okay, good. So, first of all, I recognize a few of the names in the call. So I would like to say welcome to those of you who know me already. For those of you who don't, I'm Ivan Rochford, and I'm Europe and America's manager for railway condition monitoring projects within SKF. And I'm based in Scotland. I'm also, for those of you who don't know me, I'm also not only supporting railway condition monitoring and a big fan of railways, I'm also quite obsessed with bicycles. So it's a topic which will normally occupy me for quite some time, and I thought I'd rather show a picture of me in the wild than me in a suit, because I think it's more representative of who I am. I am based in Scotland, but like I said, I have a larger role in that I'm responsible for Europe and the Americas projects, and I have in my portfolio in the region of 30 to 40 railway condition monitoring projects at any given time. I'm part of a global team. It's an internal consultancy team where we try and ensure that best practices are being followed when we're rolling out condition monitoring projects globally. So really, we're there to support the global SKF business in rolling out condition monitoring. If I just move on. So as I said, I'm based in Scotland. I had to start the presentation with a nice picture of a landmark, it's a symbol perhaps of Scotland, the Forth Railway Bridge. But first of all, what I'd like to do is just go through a few points about challenges that we recognize in the railway industry currently. And then I'll use that as the basis for the discussion moving forwards. Oops. So what's happening in your world? What we're seeing is that there is a trend towards urbanization. So we're seeing more densely populated cities, more people living in the cities, and this is placing an increasing pressure on railway infrastructure. So capacity of railway services is expected to double while still maintaining the same infrastructure. We're also seeing a trend towards globalization and liberalization, particularly in Europe, and this is resulting in increased competition within the railway industry. More parties playing, and also some of the traditional divisions that you see within industry. For example, using the UK as an example, where you've got defined rolling stock owners, OEMs, maintainers, and operators. These roles are now being challenged, and they're starting to see spillover from the traditional industry structures, I would say, where OEMs are starting to take more of a dominant role with maintenance or with the rolling stock ownership as well. So really, the traditional divisions of the industry are breaking down. Also, we see aging train fleets, and maintaining older trains is not an easy task, particularly when you consider obsolescence of parts and planning of maintenance. We know as the trains get older, towards the end of life, the demands on maintenance increase as well. And also, it needs to be recognized that there is a digitalization trend happening in railway. And I would say it's maybe the last frontier for IoT and some of the other buzzwords associated with that. But really, it's an area of significant development at the moment. So we're seeing rapid changes with the data we collect and how we use the data for railway applications. In terms of operational challenges that we recognize, like I said, we're seeing a doubling of traffic capacity on existing networks, and we need more efficient maintenance processes to reduce downtime. There's limited capacity for downtime. Also, we're looking at reducing maintenance costs to increase competitiveness. So maintenance costs still represent a significant part of a train's life cycle, and here it's estimated at 20% of the total life cycle costs. And finally, there's not room really for early failures and unplanned stops. And reliability is the key. Failures are too costly, both in terms of money and brand reputation. And just the final point, because we are SKF and rotating equipment is our business. The rotating equipment safety there are critical items, and they need to follow at the moment specific time-based maintenance manuals. And again, this places certain restrictions on how we address the challenges that I've just mentioned above. And again, just to pose the question, what if you could reduce maintenance costs, streamline and secure your spare parts supply chain without compromising reliability and missing out on technology developments? Normally during presentations like this and webinars, I would move on at this point, but I think there's an elephant in the room, which is the COVID-19 crisis. So I've added in some additional slides just to highlight some of the ongoing challenges I'm recognizing. There is a little bit of a bias here because I'm based in the UK, so some of the points I make are specific to the UK or to Europe. However, we recognize that it's a global challenge, so each region, each country will have specific challenges. So if we look at what's happening in England, what we see is that the government has suspended the rail franchise agreements, and emergency measures are in place for 6 months to avoid the train companies collapsing. And we've seen 93% average drop in passenger footfall in London's busiest stations. So really, the demand on the network has dramatically dropped. And also, this is just a quote, I think, from UNIF, which is to say that in maintaining the traffic or the railway services, the railway companies are also having to carry a considerable financial burden because the income has completely collapsed. So it's just to say that there's a significant financial burden being placed on a lot of the railway operators currently. Also, what we're seeing, and we're part of the supply chain, is that diminished production and disrupted cross-border supply chains is affecting the railway industry. And this is going to have a knock-on effect on maintenance activities. And I've heard from some customers that the availability, for example, of wheel set bearings, suddenly the lead time has dramatically increased due to closure of factories. Obviously, SKF, we have a global footprint, so we have factories globally. We're able to react to this situation, but there are other subsystem suppliers who may not necessarily be able to spread that risk globally. So increased focus on how we maintain and how we prioritize maintenance is increasingly coming into focus. Also, if we look at the Office of Rail and Road, and the advice that they're giving currently is that they recognize there are constraints to inspection and maintenance requirements. And the guidance is to prioritize inspection and reactive maintenance activities that are most critical to maintaining safe operation of the railway and the safety of passengers, public and workforce. Which is good, but how do we prioritize? And also, you'll see later on, reactive maintenance isn't necessarily always the best approach. So what's important is what we're reacting to. And I think some of the solutions which I'll go through, like condition monitoring, will help to address some of these concerns. And also some of the challenges around diminished production and supply chain disruptions could also be addressed with refurbishment and the circular economy. So I'm hoping to address some of these points, which I think may help with some of the challenges that I'm recognizing at the moment in the industry. So if I just move on to the next set of slides. So if we just run through what SKF provide. So you know us as a traditional bearing manufacturer. So we produce axle boxes. Yes, that's something that SKF does. We're well known for producing axle boxes. Axle box bearings, again, it's our bread and butter. This is what SKF does. Drive system bearings, again, as a bearing company, this is what you can expect from us. But it's this third item on the list, IoT and condition monitoring systems, that hopefully will surprise some of you. For those of you who have interacted with us, you'll know that we've been developing for the past 10 years, or even a little bit longer than that, measurement systems that are ruggedized and adapted for railway needs. And our primary focus is on condition monitoring and digitalization. And it's really changing how we approach business, but also how we hope our customers approach maintenance activities also. It's also to say that in terms of our global footprint, we have a number of global sites for remanufacture and refurbishment. We have a site in Luton, I think it's recognized here, but also I recognize this is a global audience that are in this particular meeting. We have sites around the world for refurbishment and remanufacture. In terms of manufacturing, again, we've got a global presence, global footprint right the way around the world. And it's also to say that in terms of our IoT and condition monitoring development, we have over 150 engineers who are working on the development of these systems. And we have design sites in Scotland, where I'm based, but also in Sweden, in France, in India, and in China too. So we really are increasing and continuing to fortify our development resources and teams to progress this. And I would say railway is a key focus area for us. We are developing specifically for this area dedicated solutions. And again, maybe this is telling you something that's quite obvious. You already know that SKF provide railway services, but I think there's no harm in just highlighting again what we do. So depending on what country you're in, we can provide on-site support, so on-site bearing exchange services for railway vehicles that have cartridge bearings. What is important to highlight is that we also provide refurbishment services. So some countries are better at this than others, and some customers are better at this than other customers. Some customers like to buy new. However, it can be a little bit wasteful to throw away the bearings. So there's the opportunity or possibility to refurbish those bearings and put them back in, and their life can be extended even further. And it's, let's say, it's cheaper than buying new. So I think this is important to highlight that we do refurbish bearings too. In terms of expert analysis, I mean, we are the bearing company. We have the resources, we have the expertise, and we can provide bearing analysis, investigation, and examination services. And also we have design and consultancy services, which are available on demand. Maybe, which again, like I said, might be a little bit more of a surprise for you. We do have measurement systems for railway condition monitoring. And again, I'll go through these in a little bit more detail later in the webinar, but I think there's no harm in just highlighting to you the two solutions. The one on the left here is mounted on the Axlebox and is intended for wheel set bearing monitoring, and it's completely wireless. And at the heart of what it does, it measures vibration and uses vibration to give you an early indication if the bearing has developed a damage or not. And the idea is that we move away from reactive maintenance and allow you to plan maintenance well in advance of having any issues on the track that would cause disruption. We also have a more traditional wired system, which is what you see on the right, and this is called the IMx-Rail. And this is a more powerful system because it's wired. It's got wired power going into it, which means we can more aggressively take measurements, and we can also measure more components on the Bogie system. So not only do we monitor Axlebox, but also included in scope is gearbox, traction motor. What is quite new is track monitoring. Here it says for metro lines, but we've recently extended the functionality to main line monitoring as well. And anything that rotates could also be monitored too. So it's quite a flexible system in what we do here. It's a 16-channel device, so it can take 16 cabled sensors into this particular device. It's intended to be mounted on the Bogie. And again, I'll show you pictures later on, so maybe it's difficult to visualize just when you see a black box, but this is intended to be mounted on the Bogie. And both devices are ruggedized devices. They're intended to be used in rough environments like railway. If I just move on to the next slide. And again, why have we developed these systems, and what are we trying to do, and how does this fit into our broader offering? What we're trying to do is anticipate train service issues, and again, to focus maintenance activities at where they're really needed and avoid unplanned stops. And if we go back to, at the moment, the issue around, like I mentioned, in the UK, where the guidance is to prioritize maintenance activities, this really lines up quite well with that need, that you should really do maintenance only where it's really needed at the moment. The condition monitoring enables this. Also, what we're seeing is some of the traditional measures like bearing riders or people on the train who'd listen out for bearing issues. This isn't possible at the moment in the current climate or the current crisis. So again, remote condition monitoring can fill some of the gaps that are developing at the moment too. Also, what we're trying to do, we recognize that bearings can run for longer, and we want customers to use the full potential of the bearings. And again, this is just trying to minimize the waste which we generate, and also maximize the value customers can get from their bearings. So we want to extend maintenance intervals, and using measurement systems, we can go further than the traditional approaches which prescribed inspection of the bearings. Condition monitoring allows us to extend beyond 25% increases in maintenance interval extensions. And again, I'll go through this a little bit later because I've got a slide specifically about that. But yeah, this is something that we're trying to do, getting more from our bearings. And finally, refurbishing bearings. Like I said before, refurbishment not only avoids unnecessary waste, but it'll also lower the cost of maintenance. So we believe combining condition monitoring with our refurbishment services, we can really lower costs, focus maintenance activities, and really achieve operational efficiencies in how maintenance is delivered. So if we look at, again, there's a little bit of a UK bias here. If I look at the combined service offer, this also applies, I would say, to our global service delivery. So although says SKF UK, you can apply the same rationale to any country where SKF is present. So I'm starting just as an example of one measurement system, SKF Insight. Here, customer-led installation. It takes 2 minutes to mount one of these sensors. So you can equip a whole train set in less than an hour. Really, it's very quick. I see someone's just joining, so I'll admit them. With this system, we'll record vibration signals, which will give us patterns which can be indicative of early symptoms of bearing damage. And we have a team who monitor the signals that these sensors are recording, and they will issue reports based on diagnosis that they make. So there's expert vibration analysts supporting our measurement system. So we have this analysis services that we deliver, and I would say this is a global service. We've been present in condition monitoring for decades. Sure, railway condition monitoring is a relatively new domain, so we're present between 10 and 15 years in this area, but in industrial condition monitoring, we have been one of the industry leaders for, let's say, 30, 40 years, for quite a considerable amount of time. So we're building on a significant expertise in this area. And over the last 10 years, we've been increasing the focus on mobile equipment and railway vehicles. And again, these have some peculiarities because the wheel track interaction can mean that we get more dynamic vibration signals. So it does pose some challenges, but I think we've addressed them and we've got quite a good performance, I would say, in our detections. If I look at simply just only the UK customer base that we have, we've got a 100% true positive detection rate. And I think within the industry, this is, I would hesitate to say, unparalleled. It's a significant good performance of our system and our services. We also have an established network of field engineers who can dismount the bearings. So if we have a detection made, then our service engineers can also take the bearing off and replace it. We also have specialist knowledge on bearing analysis. So once the bearing is received, we can also conduct bearing analysis. So this is something that we routinely do when we make a detection with our measurement systems. Our application engineers will review the bearing once it's back, and they can make a diagnosis of what exactly has happened to this particular bearing and why has it failed. It's possible to infer something when we inspect the bearing. And then in terms of supporting the customer, we will issue reports on damaged bearings. You can count on us for engineering support. And this, when I say engineering support, it's not just vibration analysis that we're talking about. We have bearing application engineers, mechanical engineers, people who can look to see if there's something that can be adjusted, modified, changed to avoid a recurrence again. And also we'll have routine meetings to ensure that the service we're delivering is in line with expectations of customers and making sure that it fits into, or it makes operational sense. It fits into the operational view from a customer perspective. And again, what we're trying to do is not just get into the habit of highlighting faults, which is a vicious cycle, a self-fulfilling thing. We'll constantly go around and around and around, detect bearings, dismount them, measure again, detect problems, and it'll go around and around forever. Our intention is to improve the situation as well. So we do have continuous improvement activities which we can support with. These can be redesign efforts. It can be application or failure assessments. It can also be mileage extension projects. So if we see, for example, we want to extend from 750,000 kilometers to 1 million kilometers, we can use something like a condition monitoring system to facilitate that. Also, if there's a change in the bearing design, or if we're introducing bearing refurbishment for the first time, a measurement system can assist in that process in handling or controlling the risk. So it really is if you look at it from a RAM's perspective, it can be a barrier or a way of mitigating some of these engineering changes. And In terms of our technology and the services that you can expect from SKF, again, this is quite a basic slide, but I wanted to include it before I jumped into our measurement systems and what we can measure. It's just to go through what I mean by condition monitoring, because perhaps it's not immediately obvious. And here it's a process of determining the condition of machinery while it's in operation. And the trick, which sounds blatantly obvious, but it's knowing what to listen for, how to interpret it, and when to put this knowledge into use. And when I started this presentation, I mentioned that I'm a bit of a cycling fanatic. And I can think of an example there, which is recently when I was cycling my bicycle, I could hear a tick coming through from the pedals as I was cycling. And this was indicative of a bearing failure on the bottom bracket. So having heard the noise, I understood that it was a bottom bracket problem on the bicycle, and I was able to replace the bottom bracket. And the same rationale applies when we look at railway vehicles. So there can be different things we can listen for, and different system suppliers look for different things. So again, it's common in the industry to have bearing riders or technical riders, people who ride around trains listening for problems. And again, they're listening for audible noise of something going wrong. And this generally will give a later indication of damage, so it's more advanced. Temperature as well is common within the industry. We hear of hotbox detection systems. They can be quite unreliable. We've had reports through that 95% of all hotbox detections are false. But also you've got in there in the mix vibration monitoring. And vibration typically we give a very early indication. So if we're talking about advanced indication of damage, we're usually talking in the region of months rather than days or weeks, which you might expect with other approaches. And again, if I just go to the next slide. Again, this is just to give an indication of what we're doing, the different approaches to maintenance. So railway typically, especially for safety critical components, usually apply a preventive approach to monitoring, which is the idea that we've got a prescribed maintenance interval, usually based either on time or more commonly on mileage. And after a given mileage, the bearings will be renewed or they'll be replaced, and then we'll continue running. At the other end of the scale is corrective, which is, if you look down here on the bottom right, this is an example of a fire on a railway vehicle. This is where something's already gone wrong, and then we need to react to this situation. And obviously with the safety critical component, the less we have of this approach, the better. We don't want fires on trains. And where condition monitoring and vibration analysis particularly will fit in is more in the, let's say, predictive or condition-based approach, which is that you'll give an advance notice of something starting to develop. So at this stage, we've got an early indication of damage, and it allows time for maintenance to be planned and fitted into normal operations. And this is what we're trying to do with the measurement systems that I'm presenting. So like I said before, the fault will detect or will develop quite early on, and with vibration, we'd be able to detect it very early, especially with the filters which SKF has developed for it, which are sensitive to bearing issues. But then as the defect will progress, then, I mean, at the very, very close to functional failure, it will become apparent in temperature. And this is why we also think that temperature isn't necessarily the best measure for condition monitoring, because it will generally give you a very short notice of something about to fail and gives you very little time to react as well. In terms of the systems which we have, I mentioned this earlier, but this is SKF Insight. And again, I just showed you the sensor in isolation, but I think it's valuable also to see where it's fitted on the train. So you can see here it's being mounted to the Axlebox, and a close-up of it will show that it's mounted on the top half of the Axlebox front cover. And if we look at how it's installed, if we start, again, this is a bit of a busy slide, but if you start on the top left of this screen, from unboxing the sensor through to mounting it on the front cover, torquing it up, and having it in position, and then using an iPad to commission the device, which is to say where the sensor is fitted, and applying some information about the position on the train. This whole process takes 2 minutes. So if we look at comparable systems on the market, to instrument a full train can take a full day. Whereas with us, with an Insight system, we can equip all Axleboxes on a train in, I've seen examples of less than an hour for equipping a train set. So you can very quickly roll the solution out, and it's very non-intrusive as well. So it fits quickly. It's very much a fit and forget solution. And again, at the heart of this system is vibration monitoring. So our intention with this is to give you a very early indication that damage is developing, to allow corrective actions to be planned well in advance. And again, if we're talking of a rough gauge of when or what, roughly how far in advance to plan maintenance, we're talking usually months in advance with a system like this. We also measure temperature, and the idea is to complement some of the temperature monitoring systems that are already in use. So, for example, if there's been a wayside hotbox detection, and again, we know that the reliability of these can be a little bit suspect at times. Being able to check what the trends are from our sensors will also allow you to get a feeling if it's a valid alert or not. They take temperature every 10 minutes. So it's something that we move with the train, we follow the temperature trends. So if for whatever reason there's an issue which hasn't manifested itself in vibration, temperature is there as the last safety net with a system like this. We also, I mentioned the other system which we have is the IMx-Rail, which is fitted to bogies. And really here it depends on the bogie design, the train design. This can be mounted either on the underside of the carriage, on the bogie itself. We also have some variants of this product which can be rack mounted inside for OEMs. So here, the primary target here with the IMx-Rail is the OEM market, so the train manufacturers. However, it can also be retrofitted. It's got wireless communications, but you'll see that there are a number of cables going in here. And the idea is that the components for monitoring have cabled sensors. And also we've got cabled power coming to this, but it's got wireless communications. And again, being mounted on the bogie itself, it's quite a rugged device. It's designed for that exposed location. And like I said before, well, here's a squiggly line showing what vibration looks like. This is intended to detect early symptoms of bearing damage, but because we can also monitor things like traction motor and gearbox, some of the other failure modes, for example, like cracked teeth on a gear wheel, this is something that we can detect also with a vibration monitoring system. This device also supports temperature monitoring. And again, if you wanted to measure temperature, we have combined vibration and temperature sensors, so we can give you a 2-for-1 if that's something which was of interest. What's new here is track monitoring too. And some people might question why SKF is weighing into infrastructure monitoring when we're the bearing manufacturer, but we have to recognize that bearing condition is somehow linked to the quality of infrastructure we're also running on. And we also know this dialogue between operators and infrastructure owners can be a little bit of a fraught relationship too, because track condition can damage the vehicles. So we recognize that the track can have an impact on our bearings. So we want our bearings to run as well as possible and to be as healthy as possible. So the infrastructure is relevant and in scope for us too. Also gives an opportunity to bring more stakeholders into a condition monitoring project and get more value from the solutions which we're delivering. Just to give you an example, this installation that you're seeing here was on Barcelona Metro. So these aren't solutions which are just ideas or nice things. These are things which are genuinely in the field. If I just scroll back up again to Insight and just highlight this is something which is now being run in Europe, America, and Asia. We have thousands of sensors installed. And like I said before, with Insight, we've got a 100% confirmed detection rate. And yeah, I think we're doing quite a good job at the moment with the services we're delivering with this system. IMx-Rail, again, is targeting more the OEM market. And with track monitoring, we have a number of pilots ongoing. It's a relatively new product in our product line, but we have a history of similar products as well, which have been in the market and have been around for quite some time. So we have, let's say, within this family, a history of other devices like the IMx-B, the IMx-OR, Mascon in the past. So between 10 and 15 years, this solution has been around. What's changed most recently, track monitoring. We've made it cheaper, which is good news. And also it's more powerful, and it's benefited from some of the advancements in electronics. Again, I've talked a lot about the systems, but it's good to see what the output of the systems are. And again, these will look like squiggly lines on top, but what you'll see is that there's a certain pattern appearing, harmonic activity in the spectrum, and each of these will have this present. And each of these symptoms, I know, correspond to a particular component within the bearing. And here it's the outer ring. But with vibration, we can tell you not only that the bearing is damaged, we can tell you which component in the bearing is damaged, whether it's the roller, the outer raceway, the inner raceway. Cage can be a little bit more of a challenge for railway, but it's still monitored, and I have yet to see an example of cage failures coming through in the projects that I'm supporting. But certainly outer ring damage is quite common, I would say. And again, because we're providing bearing analysis services and also refurbishment services, we do get access to the bearings that we've detected. So we can tell you what one damage looked like and what another damage looked like, and that there is correlation between the signals which we're seeing. Also, if I just scroll on to the next page, just to say that in the background, what we're trying to do is put a little bit of substance to some of the claims that we make in terms of advanced notifications. So we know that spalls can last for a significant period of time in the field prior to functional failure. But what we're doing is we're also running a battery of tests. They started initially in our research center in the Netherlands, in Nieuwegein, and we've continued or sustained this now in Schweinfurt in our testing center there, where there are long-term testing going on with measurement systems and damaged bearings, which is counterintuitive for a bearing manufacturer. Normally we'll stop a test when damage appears. Instead, what we're doing is we're starting with the damage and then running it truly to catastrophic failure and monitoring the response in our signals. And our goal here is to have a body of work which can substantiate the claims of extending for running months from initial detection. So the goal is 3 months advance notification. We know for some of this testing that there are instances where we can give you much more than 3 months advance notice of bearing damage, but it's something that we are working towards. There's also teams of data scientists supporting this activity, and it's an area of significant development activity at the moment, this particular area. To give you an idea of some of the other damage which we can detect, again, we've got instances where we can indicate when a wheel needs to be reprofiled. So you can see very clearly, we've got a specific filter that's focused on wheel condition, and it's sensitive to slaps, bangs, and rumbles. And again, we've seen a clear correlation when a wheel needs to be reprofiled, and when it has been reprofiled, you'll see a drop down in the trend, and then over time it gradually increases, and then they reprofile and it drops down again. So this is something we can deliver. Also damages to gear wheels and pinions. This is something that's possible with our measurement systems, and also again traction motor bearings to samples from the field. Again, how this fits into the maintenance approach in RAMs, condition monitoring offers the opportunity to have an additional barrier in the fault tree analysis. So the idea is we want to have a very early indication before we get to the stage where we have noise or high temperature, cages melting, or bearing jamming. Condition monitoring offers the opportunity to pick this up and have corrective actions applied at a very early stage. So it fits in to the RAMs philosophy and the RAMs approach. Something which is also maybe of interest for those on the call is that we have released a new process for extending maintenance interval, which includes condition monitoring in there. So the traditional DIN standard requires inspection of the bearings. And now what SKF are recommending that for extensions beyond 20%, we mandate the use of measurement systems or condition monitoring systems, in addition to some limited sampling from the fleets. So we can go a lot further than what was possible in the past. And also as bearing OEM, we're uniquely positioned to underwrite changes to the maintenance manual where it's applicable. So if we just go to, again, this is the last slide in the slide pack, but it's just to reiterate what we're trying to achieve, because I've talked about systems, I've talked about services, I've talked about some detection examples and a lot of activities, but really what's underlying this, again, is that we believe with the combination of services we have, we can anticipate train service issues and early and focus maintenance activities where they're really needed, prioritize what we do, and avoid unplanned stops. We don't want fires on the track. We want to be detecting things very early on. Also, we believe our bearings are capable of running longer, and we've got systems which can control the risk of exercises in changing the maintenance manual and extending maintenance intervals. And again, this is a combination of SKF application engineering, some of our inspection services, as well as, depending on how far you want to stretch it, if beyond 20%, you can also include condition monitoring to support this activity. And finally, refurbishing bearings. It sounds very straightforward, and in some countries this is routine, and in some customers it's routine. But if we refurbish the bearings, we'll get more from them. We avoid unnecessary waste, but also it lowers the cost of maintenance. And again, SKF have a number of remanufacturing sites globally, and we can support this activity. So again, just to summarize, we want to avoid train service issues, we want to extend maintenance intervals, and we want to support you in refurbishing bearings. So finally, if you've had your interest piqued and you want to find out more about what I presented, feel free to contact me. This presentation will be shared after this particular webinar, and I think the webinar has also been recorded and will be available. The details are here. I'm available on LinkedIn, so please reach out to me if you need me. My email address is here. Email me, call me. I'm available to support you. My reach is global. My focus is primarily on Europe and the Americas, but I'm part of a global team, so I appreciate this is a global audience. So if you have interest and you're not from Europe or Americas, please reach out to me anyway. I'm sure I can find someone to support you in any case. For those of you in the UK, my colleague Stephen Dixon supports sales, so he can also handle some of your queries. But reach out to either of us, and I'm sure we can help. Now, I'm conscious I'm quite punctual, so I'm not sure there's a lot of time for questions. I don't see any questions in the meeting chat. However, if anybody does have any questions, I would recommend that you email me, and what I'll do is I'll try to respond to it. We have unfortunately run out of time now. So what I would like to do is to thank you for joining this webinar, and I hope it was insightful, and I hope you found it helpful. And again, if you do have any questions, queries, concerns, comments, reach out to me. I'm happy to respond. Okay, so that's the end of the webinar. So thank you all for joining, and I really appreciate your participation. Okay, thank you.